Alright, hello, my name is Floyd Bolden,
And then my name is Isaac Chubaga.
and today we're going to do question 16 on chapter 9, level 3 of this question. Alright,
The question says, air in a 120 kilometer per hour wind strikes head on the force of a building 45 meters wide by 75 meters high and is brought to the rest. If air has a mass of 1.3 kilograms per cubic meter, determine the average force of the wind in the building.
alright, so in this question, we know that our knowns are going to be 120 kilometers per hour. That's going to be our initial velocity. So I'm going to put V is equal to 120 km over h. Then second part is our dimensions. We know it's 45 by 75 meters high. So I'm gonna go ahead and write that right here. Length is equal to, width is equal to 45 meters. And then height is equal to 75 meters. All right, and then we know that the mass or the density of the air is equal to 1.3 kg per cubic meter. So I'll put mass So I'll put kg over m to the third. Then that's all of our knowns at this time.
All right. So the formulas that we'll be using is the momentum formula, the force formula, which is momentum over time, change of momentum over the change in time, which can be derived to the change in m, or the change of mass over the change in time, times velocity. And then we use the area formula, which is length times width. So I'll write it down. So you have first the momentum formula, which is P m over v, and then now you have the force, which is change in P over change in T, which can be derived to change in M, the derivative M, and then the derivative T, times velocity. And then lastly, you have area equals length times width. And then for P would be momentum, N would be mass, V would be velocity, F would be force, P once again, momentum, time, then mass over time. And then area equals length times width.
All right, and now for the math. All right, so pretty much you want to start off with finding our area, which is of course the width times the height, or length times width, which is 45 by 75. Which is equal to 3,375 meters per meter squared. All right, then after that, we can find our velocity per second, which is derived from the area times the velocity itself. So I can write that down real quick. Times the velocity. But in the equation, it says our velocity is 120 kilometers per hour. However, we had to convert it into meters per second. In that case, we'll multiply by the constant to get the meters per second, which is, I'll just write it right here. Which is equal to 33.33 meters per second. All right, then we can plug it into this equation right here. Multiply the area by the velocity, which is, the area is 3,375 meters per second times the velocity, which is 33.33 meters per second. All right, in that case, what we get is 120,500 meters cubed over a second. All right, after that, I'm sorry, 112, not 120. All right, after that, we can then find our mass flow rate, which is equal to the density of the air times velocity per second. So with that, we know that the density of the air, or the mass of the air, is equal to 1.3 kg over m cubed. So I'm going to write the formula right here. I'm going to erase this right here. Give me one. So mass flow rate, or in this case, mass flow rate is also equal to dm over dt.
Yeah.
Mass flow rate, just to make it simpler. All right, so we got mass flow rate is equal to density of the air times the velocity per second. All right, in that case, we can plug in our values, which the density of the air is equal to 1.3 kg m cubed times the velocity per second, which we got 112,500. All right, meters cubed over second. All right, in this case, we know that the two m cubes canceled out, and then what we were left with is our total, which is 146,250. And then our value is, of course, kg over s. All right, so after that, we found our mass flow rate. So from the equation above, we can multiply that by our initial velocity, which is 33.33 meters per second. And then we can find our force. All right, so we got F from the equation before.
Oh, my fault.
No, you're. All right, so going back from the equation that we had before, we got force is equal to the change in P over the change in T. I'm sorry, the change in mass over the change in time times V. I'm gonna go there. And then of course, this is our mass flow rate right here, which is what we got is 100,046,250. So I'll move this up. I'm sorry. All right, so we got 146,250 kg over a second times the V, which is 33 meters per second. And then of course, we're gonna get our total, which is 4,875,000 m over s squared, which is equal to newtons. So I'm going to put it in scientific notation down here. And that is our answer. All right, that's it. Our total from the equation is 4.88 times 10 to the 6 newtons.